Alright, here is a short video to explain how to draw the Lewis structures of covalent molecules. Well, both of these are covalent molecules, as you can see here. Carbon, hydrogen, fluorine, they're all nonmetals. You have hydrogen and oxygen, which are also nonmetals. So when you have a molecule made of a nonmetal and a nonmetal, we usually call it covalent, which means these atoms share electrons. Nonmetals share electrons to become stable. So the first thing that we need to understand is, again, these subscripts 2 means that there are 2 atoms of hydrogen in one molecule, and there are also 2 atoms of fluorine in the same molecule. So let's write the electronic configuration of the individual atoms. So there are 2 hydrogens because it's H2, and since it is F2, there are also 2 fluorine atoms. So the electron configuration of carbon is 2 and 4. Hydrogen is 1, the other hydrogen is also 1. Fluorine has 9 electrons, so the electron configuration is 2 and 7. This fluorine would be 2 and 7. Now let's show just the valence electrons. So carbon has 4 valence electrons, or 4 electrons in the outermost shell. Hydrogen has 1. The other hydrogen also has 1. Whereas fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7. You have another fluorine which also has 7 valence electrons. That's 1, 2, 3, 4, 5, 6, and 7. Now when you draw the Lewis structure of this covalent molecule, difluoromethane, CH2F2, looking at carbon and fluorine, you can say carbon has fewer protons, so that will be usually shown in the center, and carbon is also the atom that is going to share the most number of electrons. So since carbon has 4 electrons, it requires 4 more electrons to become stable or to get a full outer shell, whereas hydrogen need only 1 electron. Whereas fluorine has 7 valence electrons, so it requires 1 more. So carbon needs 4 more, whereas hydrogens need 1 each. Fluorines need 1 each as well. So since carbon needs 4 valence electrons more, so it is going to share, these are the 4 valence electrons of carbon, so it will share 1 each with the hydrogen. So it will share another valence electron with the second hydrogen. It will share the 3rd valence electron with another fluorine. It will share the 4th valence electron with the other fluorine. Now as a result, carbon has 8 valence electrons altogether, if you can see. That's 2, and this is 2 as well, and that's 2 as well. Now carbon has, that's 8 electrons around it. So since fluorine has used 1 out of 7 for sharing, it now has 6 valence electrons remaining. And this fluorine also had 7, it used 1, it gave 1 for sharing. So out of 7, 1 is used for sharing, so it now has 6 valence electrons. So as a result, the hydrogen has 2, carbon has 8, and fluorine also has 8 electrons. So the shared electrons belong equally to both atoms. If fluorine gives 1, carbon gives 1, that shared pair of electrons belong equally to both carbon and fluorine. So as a result of sharing of their valence electrons, all the atoms in this molecule CH2F2, they're all stable. Now let's take a look at H2O2. So H2O2 is basically, excuse my drawing, which means, again, in one molecule of hydrogen peroxide, H2O2, there are 2 atoms of hydrogen and 2 atoms of oxygen. So let's write that 2 atoms of hydrogen and 2 atoms of oxygen. We do the same thing. We write the electron configuration. Hydrogen has just 1 electron. Oxygen has 8 electrons, which can be written as 2 and 6. This could be 2 and 6 as well. Now let's show just the valence electrons of hydrogen with a cross. This hydrogen is also a cross, and each oxygen has 6 valence electrons. So let me use a dot. That's 1, 2, 3, 4, 5, 6 valence electrons, and this oxygen also has 6 valence electrons. 1, 2, 3, 4, 5, 6. So hydrogen needs just 1 more electron to become stable, whereas oxygen has 6. So hydrogen needs 1 each, whereas each oxygen atom requires 2 more electrons to become stable. So since hydrogen requires only 1, it's going to share 1 electron with that of oxygen, and this oxygen will share another electron with oxygen. Now this oxygen will share 1 more electron with the hydrogen. So each oxygen shares 1 electron with hydrogen and 1 with oxygen. So now oxygen had 6 valence electrons. Since 2 are given for sharing, there are 4 electrons remaining on oxygen. And this oxygen also originally had 6 valence electrons, and it gave 2 for sharing, so it now has 4 valence electrons. So in other words, this hydrogen now has 2 valence electrons, so that's stable. This hydrogen also has 2 valence electrons. That hydrogen is also stable. Now each oxygen has, that's 2, 4, 6, and 8. That oxygen is stable, and this oxygen also has 8 electrons. 2, 4, 6, and 8. And as I mentioned a few seconds ago, the electrons that are shared belong equally to both atoms. So the structure of hydrogen peroxide would look something like this. So there is a single bond between hydrogen and oxygen, and also there is a single covalent bond between oxygen-oxygen. So a single covalent bond usually is made of 2 electrons, and these are the electrons that did not or didn't participate in the covalent bond. Right? So ultimately the goal of covalent bond formation is basically to let the atoms become stable. In other words, to let the atoms get a full outer shell. And that completes the video on Lewis structures of covalent molecules.